So in our last lesson we solved inequalities. Well, look at the title of this notes. Solving absolute value inequalities. Alright, well, how do we handle solving absolute value inequalities? Well, what you see all there right before you is hopefully a guideline that's going to help us keep it all straight. Our objective is to solve and sketch the solution on a number line. Alright, so if we're dealing with an absolute value and it's less than a, some number a just represents a number. After we've isolated the absolute value, if that absolute value is less than a, the solution would be all values between negative a and a. What we're going to do is that we're going to take this kind of inequality and we're going to set up a compound inequality and put the expression that falls between the absolute value in between negative a and a. Our work in the last video had us do something similar to that. It's just now our turn to decide that we need to set the problem up that way. Alright, well, what happens if the value of the absolute value is greater than a? Well, that's going to be all values less than negative a or greater than a. And so what we're going to do to set up the problem is if we encounter an absolute value that's greater than a, like in example 1, it means that we have to set up two different problems. One where the expression between the absolute value bars is less than negative a, and one where the expression between the absolute value is greater than a. So always connect back to what do we have up here. Great guidelines. I mean, the hope would be that you could memorize it, but I don't know. That's a lot to memorize. We have these guidelines here. Alright, so in example 1, the absolute value of 6x is greater than 12. Well, the nice thing is the absolute value is already isolated on one side of the inequality. So now what we have to do is we have to look above. Well, let's find the greater than symbol. Okay, well, it's this last one here. So what we need to do is we need to remove the absolute value and replace these x's with 6x and these a's with 12 and negative 12, and we'll be good to go. Alright, so removing the absolute value, so 6x, I'm actually going to start with the greater than first just because it's natural for me. If I remove the absolute value, I just rewrite the problem the way it is. And then I'm going to use the word or, but I keep the 6x, but when I put the less than symbol, it's got to be negative 12. So just remove the absolute value, keep everything else intact, and if it's the greater than symbol, then put or with 6x is less than the negative 12. So that's what this statement is. So divide both sides by 6 here, x is greater than 2, or divide by 6, x is less than negative 2. Alright, so the instructions are to sketch our solution on a number line. So we have negative 2 and 2. So x has got to be greater than 2, and x has got to be less than negative 2. So you kind of have one branch going on either side. Okay. Alright, our absolute value is isolated. Let's not worry about the division by 3 yet. Once your absolute value is isolated on one side of the inequality, notice the inequality is less than, so we're coming up here. It's less than or equal to, but we can make that adjustment easily. Alright, so with a less than, that means that we're going to take what's between the bars, the absolute value bars. This one's easy with less than. Okay, and we're going to say greater than or equal to negative 3 and less than or equal to positive 3. Negative 3, positive 3, x over 3 in here. Next step, multiply everything by 3 to clear the inequality of fractions. So multiply everything by 3, positive 3. Our solutions to this original problem would fall between negative 9 and 9, inclusive. Alright, let's see if they get just a slight more complicated. Alright, the absolute value of x minus 10 is greater than 2. So what replacement for x when we subtract 10 would give us a number greater than 2? Well, the absolute value is already isolated. It's by itself. So we just look at the inequality symbol. It's greater than. It's the last thing on your paper. So my suggestion is remove the absolute value, keeping everything intact. Put or x minus 10 is less than negative 2. You're going to reverse the symbol and change the sign. All right, let's add 10 to both sides. So either x is greater than 12, or when I add 10 over here, x is less than 8. So the solution set would have us choose a number that's greater than 12 or less than 8. So let's see what that looks like. In order, let's put 8 and 12 on a number line, both open circles. Less than 8 this direction, greater than 12 that direction. Right, our absolute value is already isolated. You'll see what I mean in just a minute. It's already by itself. I didn't have to add or subtract or divide out anything to isolate the absolute value. So we have the greater than symbol, just like in example 3. So it's going to be another or statement. So remove the absolute value, keeping everything else the same, or x plus 2 divided by 3 must be less than or equal to negative 4. Now let's clear the fractions, multiply everything by 3, so x plus 2 is greater than or equal to 12. Subtract 2, x must be a number greater than or equal to 10. Let's come over here and finish our work. Multiply by 3. Subtract a 2. And again, that's or. Let's do a number line, putting in order. Negative 14 would fall to the left of 10. Close circles. Let's go back for further directions. X must be greater than 10, or x must be less than or equal to negative 14. Okay, let's solve one more absolute value inequality. All right, let's say that your absolute value is not isolated. There's more happening. So, well, you have to isolate it first before you can separate like we've done up here. All right, let's divide everything by 7. Well, dividing by 7 is going to result in isolating the absolute value. Dividing by 7 gives 3. Absolute value is isolated. We have the less than symbol. Less than means we're going to place 2 minus 3x in between 3 and negative 3. All right, let's subtract a 2. Negative 5. Less than 1. Divide everything by negative 3. Remember what that means. In your next step, you'll reverse the symbols. So x greater than, and there's not much you can do here, so it's negative 5/3 and 1/3. And on this piece of paper, I'll come up here and do the solution. All right, how are you going to put that on the number line? Well, as easy as this. Open circles. Look back for further directions, kind of built-in check process. X has got to be greater, though, than 1. Oh, did I not divide? I thought I put the negatives there. So this would be positive, and this would be negative. Let me adjust this over here. Give me just a second. All right, take a look at that again. I think that's right. I thought I put the negative. Sometimes the pen takes it off, but it could have been that I didn't put the negative there, but all is well. Divide by negative 3, divide by negative 3. Yep. So now it makes sense. Okay, and maybe if we switch this, I might have caught it sooner. If I put the negative 1/3 over here and the 5/3 here, yeah, because this could be the only ordering in which that would make sense. So x has to fall between negative 1/3 and 5/3. So there we go. So solving absolute value inequalities. All right.